Welcome, students. Today we see about the topic conduction and its heat transfer through the planes and composites part. Okay. So before we go conduction, what is the transfer of heat present in this discussion? Okay. So heat transfer. So what is meant heat transfer? Before we know that heat transfer, what is heat? Okay. So heat is nothing but it is energy. Okay, is one form of energy. We should be in transit. Okay, so heat is a major source energy. It's available in the world. Okay, even we have the heat. Okay, human body have the heat and each and every one having the heat to run the world. Okay. So heat is a major source in the world. We should be having the transistor. Okay. And you cannot store the heat energy. Okay, it should be transient because it's from high temperature to low temperature region in spontaneously. So the mode of heat transfer is having the three modes, that is conduction, conversion, and radiation. Okay. So conduction is nothing but it is transfer of heat. Okay, so showing in this big picture. So this is the conduction. Transfer of conduction, it will be from solid to solid. Okay. So the transfer heat from region of high temperature to low temperature with medium of solid. So it is a pure conduction mainly make in conduction. That is a solid to solid. Okay. So in conduction, energy exchange it should be taken place within the direct impact of molecules. Okay. So the pure conduction is only found in solids. So next one is a convection. So another mode of heat transfer is convection. So the convection is nothing but it is a transfer of heat from solid surface to fluid medium. You already see that is a solid surface. One second. So you already see solid surface. That is a this is a solid surface. Okay, this is a part having the solid surface. Heat is transferred to solid to inside having the fluid medium. That is a liquid medium. Okay, so the heat is transferred to solid to fluid. So that is the convection. Okay, so convection is possibly only in presence of fluid medium. So you know that the fluid means the fluid having the both liquid and gases. Okay, so for example, we're taking a cup of coffee. Okay, so it should be placed in atmosphere. Okay, the air is passing, so the air is present in the atmosphere. The temperature of a cup of coffee is 70 degrees Celsius. Okay, the temperature of cup of coffee is 70 degrees Celsius. When placed in atmosphere temperature, it becomes reduced in, for example, the 30 to 35 degrees Celsius atmospheric temperature, which will be compensated. The air is present in the, okay, so 70 degrees should be reduced to 30 degrees. So the means of heat should be transferred. That is, the temperature should be reduced. That is from low high temperature to low temperature. That is a convection. Okay, the state of solid to fluid medium. Fluid medium nothing but that is a liquid or yeah or gas. That is a fluid medium. The transfer of solid to fluid medium is a convection. Okay. So then another one is a radiation. The third mode of heat transfer is a radiation. So radiation is nothing but the transfer of heat. So heat should be occur to transfer heat from one source to another source without transmitting medium. So without any transmitting medium present in the radiation. Okay. So for example, the heat from the fire burn it should be transferred to atmosphere without any source. That is the form of electromagnetic wave phenomena. Okay. Okay. So the type of electromagnetic wave should be classified of wavelength of propagation of light of speed. That is speed light. The speed of light that it should be that is 3 into 10 power 8 meter per second. Okay. So it is transmitting the heat. So even the conduction or convection or radiation, it should be a transfer the heat with different modes. Okay. So solid to solid is a conduction, and solid to fluid is a convection. And so we go the heat transfer without any transmitting medium, that is a radiation. So even though it take place of heat transfer is not possible to individually record by conduction or convection, should be possible to either conduction or convection, or conduction or radiation or convection radiation. It should be transfer of heat should be placed in these modes. Okay, once again, that's a mode, and we go for some law related to heat conduction. Okay, so first one is a Fourier's law. The Fourier's law is a very important law to study about the heat transfer rate from one region to another region. That means high temperature region to low temperature region. Okay, so that should be studied. So Fourier's law is developed by Joseph Fourier. Okay, he's a French scientist. He developed the Fourier's law of conduction. So that law said, so that law said, one sec, yeah, the law said the rate of heat transfer is direct proportional to the what? Rate of heat transfer proportional to the area and heat flow. So that represents the normal direction. The normal direction nothing but the direction is perpendicular to the heat element. That is the element required. That is a metal or related to metal element. There should be transfer of heat. That is in perpendicular direction. That is mentioned as the normal direction of heat flow to the temperature gradient. So temperature gradient is nothing but a change in temperature with respect to some distance. Okay. So we know that the distance is a x from this to this. For example, you've taken as a 1L initial to final, that is the initial temperature to final temperature. In between, we have the element. The element have the thickness. That is, it becomes a x. Okay. We know that this particular area of heat conduction. So that means you separate the element in the each and every part. So this distance represents the dx. Okay, that is the difference between x and dx. So we find out the minute area, so my separate area. So you find out the differentiation. That is a dt by dx. That is a temperature gradient. Okay, so the k value mentioned there. So k value is nothing but the thermal conductivity. We know that each and every material having the conductivity, there is a thermal conductivity. Okay, so higher we use conductivity of the element based on the temperature transfer. There is a heat transfer. Okay, so from higher to lower temperature or lower to higher temperature, if you use a heat transfer, it becomes low to, sorry, higher to lower temperature. and and our standard measure the temperature like different variables that like Celsius, Fahrenheit, or Kelvin. Okay, so in Indian standard we use a Celsius, but we use the formulas in problems we use a Kelvin. So we know that temperature degrees Celsius into Kelvin with help of plus 273 we get the Kelvin value in temperature. We know that the temperature difference. So we call heat temperature, heat transfer. Heat is nothing but I already told heat is the energy. Temperature is a measuring unit of heat. Even though it becomes a measuring unit of cooling, also is a temperature. Okay. So this is one of the example of heat transfer from human body. We know that the solar radiation it's one of the heat transfer without transmitting the in between sun and yeah, that is one of the example of radiation heat transfer radiation. Okay, transfer of heat from sun. So from your body creating the heat, you source when we run the we use the heat inside the human body. So that transfer of heat, we work hard, we do the heat is released from our body. That heat is throughout the ground. That is a conduction. Okay, so from here to here, there is a conduction. You know, the example. So this is the example of heat transfer from our body. Okay. Okay. So some of the materials as given in this slide, we have the thermal conductivity. We have a high thermal conductivity in the pure silver, that's a 418 conductivity from water meter Kelvin. Okay. So we have air as a low thermal conductivity, that is 0.025. Okay. These are the material having the thermal conductivity. So thermal conductivity is refers to that means ability to transfer the heat or conduct the heat. That is a thermal conductivity. Okay. So it should be denoted as K. So otherwise it denoted as a lambda. Okay. So we should be use a thermal conductivity or symbol like a Kr lambda. Okay. So what is thermal resistivity? That is a reciprocal quantity of the thermal conductivity is a thermal resistivity. That means conductivity, it should be transfer of heat. So without use of heat, that does not the material conduct the heat. That is the thermal resistivity. Okay. So the materials with high thermal conductivity we use it within the low value, that is used as a thermal insulator. So thermal insulator, that is represent the heat should be transferred from one material to another material, or one medium to another medium. With use of insulator should be reduce the temperature. Okay, so that is a thermal insulators. Okay, once again I recall what is the modes: conduction, convection, and radiation. Okay. So simply say the conduction is the transfer of heat. So the three modes are transfer the heat. Okay. So conduction is transfer the heat from solid to, that is solid to solid. Okay. So convection, the transfer of heat from solid medium to fluid medium. The fluid, I told you, fluid is a liquid or gases, or said as a fluid medium. Okay. So in radiation, it transfer the heat source from this to this without any transmitting medium. That is the radiation. Okay. That what on electromagnetic phenomena. We told you example from heat source from sun to earth, or use a boiler area becomes a radiation to transform transmitting medium. That is a radiation. Okay, next we study the transfer of heat using different medium like a plane wall, cylinders, and spherical system. Okay, so we know that plane wall. This is an example of plane wall. The transfer of heat from this region to this region. We have the temperature directly as a T1. This is T2. There's a metal. I think they use a silver or aluminum. Use a silver metal. Okay, so there is a metal use a silver. You know that thermal conductivity of silver. Okay, so there is a K value now, and thermal, for example, temperature 1, you have 700 degrees Celsius. So input temperature. Okay, so heat should be conducted, should be from silver metal. That is a plain watt. Okay, so exit temperature, I think nearly 600 degrees Celsius. Okay, so the heat is absorbed by, or element, the heat element should be absorbed by nearly 100 degrees Celsius, because we having the thermal conductivity of the silver. Okay, so you find out the rate of heat transfer. So why we can use of Fourier's law? We find out the how much amount of heat should be transferred from inlet to outlet. We can heat should be stored within the element. Already I told you, heat is not stored, but it should be absorbed by heating element. So that, sorry, absorbed by element. So that should be find out the rate of heat transfer. Okay, so that is a Q. So we know that Q is equal to minus K A minus Ka. One second. So Q is equal to minus Ka dt by dx. Okay. So we know that area. So area of the element we find out the, and thermal conductivity we know that silver, or silver thermal conductivity. Why we use a negative symbol on this formula? Because we use a temperature, that is a dt means change in temperature, difference between T1 and T2. Okay. So for example, we give the 700 degrees Celsius, there is a 600 degrees Celsius, that represent the T2 minus T1. Okay. So the T2 minus T1 means the 600 minus 700 become the negative value. So we balance the negative value, we use a minus on the equation. Okay. So why we choose the formula? We use a negative value because we get the negative value from the output temperature difference. So we use a negative one balancing the equation. Okay, and then we go for cylinder. So we use a plain wall. Okay, so we have different problems on plain walls and cylinders and spherical system. So if plain wall, we have another method, that is a plain wall represent the composite wall, because we use a silver. Okay, so again we use a copper, or the aluminum, again silver, copper. Okay, so these are the composite walls. Okay, the inlet temperature we give 800 degrees Celsius. We get we did not know how much amount of energy should be, or temperature should be outlet. Okay, so each and every metal having different thermal conductivity. Okay, So we find out the individually of rate of heat transfer, use of Fourier's law formulas from each and every metal. So finally we get the outer temperature and heat transfer rate. Okay, so and silver has different conductivity, thermal conductivity, copper and thermal conductivity, aluminum has different conductivity. So there is a uh, copper another having thermal conductivity. Cool. So this method of find out the plane wall. So already we know the cylinder like this. Okay, so cylinder like this, a hollow cylinder or plain cylinder. So that represents a solid cylinder. You find out the inlet temperature T1 and the exit of T2. So that's why you find out the temperature of heat transfer from cylinder metal. So when you hollow cylinder like this, okay, so we having the radius various. Yeah, you have a single radius, so or one only. But if you have hollow cylinder, so the inlet radius and outlet radius, we give the value of T1 and T2. We find out the heat transfer rate. Okay, so next class we see about the derivations about plane walls and cylinder. Okay, we use of general heat conduction equation. We find out the heat transfer rate. That is a heat stored in the element or heat generated within the element. Okay, so spherical system, there is a spherical system. We have two types of having find out the spherical system, you hollow spherical or solid spherical. So similarly, we find out the cylinder and plane. That's related to the spherical system. Okay, so so next class we see about the problems related to the plane walls, cylinders, and spherical systems. Okay, okay, thank you. So so already told that first again I recall what I've studied today. There is a conduction. We find out the conduction is one of the heat transfer. Okay, so heat transfer having heat is one of the energy, is a major energy. Okay, it's one of the energy, is a major energy. It is a represent the in transit. It should be changing. Okay, so it should be changing even from higher to lower. In it becomes a spontaneously. Okay, and then we cannot be stored the heat in particular area or particular region. Okay, we should be in transformation from higher to lower. Okay. Already told heat transfer having three modes: conduction, convection, radiation. The conduction is that solid to solid. Conduction represent the solid to liquid, and radiation is a heat to heat source without any transmitting medium. That works on electromagnetic wave phenomena. Okay. Next class we study about the plane wall, cylinders and spherical system. And plane wall having two types. There is a solid plane wall. So single metal should be transfer of heat from one to inlet to outlet. Plane wall. Another one is a composite wall that represents the different metal should be placed arranged in the series. We find out the heat transfer rate. Okay. Okay, thank you.